This next one is going to involve horizontal transformation or horizontal shifting, rigid horizontal movement. So again, well, by rigid is just that if we move the object, it doesn't change its shape, right? All we're going to do is move horizontally. Now, what occurs to the function f of x when we transform it by adding or subtracting a constant to the domain variable? That is, we're going to look at it from this perspective. So f of x plus b, or subtract x minus b. What does that do to f of x? So whenever we transform by affecting the domain variable, so notice the function, the rule does something to whatever you enter. But what this is saying is that we're going to change the input by adding b to it or subtracting b from it. It appears, okay, so whenever we do that, it appears that the opposite of what we write down occurs. There's a simple explanation for this, which will make clear it is best just to observe what occurs by experimentation, then come up with an explanation. So we're trying to explain right now. It's not going to make more sense, but you see that it happened a few times, and then we're going to offer an explanation. The graph of fx, square root of x is shown, which again looks like this. Let us use Desmos to determine what f of -3 looks like. We bring Desmos over. Fantastic. And I'm going to type f of x equals, and then we go sqrt x. Great. So now I've defined what f of x is. So now I'm going to come over here and type f of x minus 3. And this occurs. It looks like, if I'm not mistaken, I've taken the point and moved it 1, 2, 3 to the right. That's what appears has happened. In other words, I'm going to come over here. Let me write it down on this piece of paper now. So 0 has moved to 1, 2, 3, and it's now sitting right here. Let me find another point that I can clearly see, and that point is 2, and it looks like it has moved also 3 units if I looked at my graph. So it would be now 1, 2, and I'm going to have to make a little point right here, and 3. So it's moved again 3 units. To the right. So when I try and graph this, 1, 2, 3, 3, I get this picture. Yeah, that's about right. So I'm going to bring the graph right back. And that looks what I am getting when I try to do this by hand. Yeah, get a little bit fooled because of the areas here are a little bit off, but notice you can see that here as well. But it hasn't been deformed in any way. It has just been shifted over 3 units to the right. So the result of doing this is that f of x minus 3 is f of x shifted horizontally three units to the right. What does f of x plus 5 look like? Here, and find my function. It's got in the way here. I can't grab my screen. Back. f of x plus 5. Over a little bit. Now it looks like I have shifted 1, 2, 3, 4, 5. 5 units to the left. So now it looks like I've taken this point and moved it all the way here to -5. So that means that this other point that used to be 4, 2, now is that moved over to the left 5. Let's see. Here's my original 2. Let's see. 1, 2, 3, 4, 5. Indeed, it looks like I have gone 5 over. So 1, 2, 3, 4, 5. Oh, is that right? I have 1. So that has been 1, 2, 3, 4, 5. Yep, there it is. And if I start connecting these two, start getting that picture that I have here on my screen. As a matter of fact, I can't see here, but I know this is square root function, so square root of 9 is a 3. So the 3 that was here has now been shifted. And where is it now? Let's see. So now there's a 3. The output of 3, in other words, square root of 9 is 3. There's the 3, and it's now happening at 4. So at 4, I'm getting the 3 to pop out. I'm getting this picture here. So it looks like f of x plus 5 has shifted horizontally. F of x 5 units to the left. The confusion starts when you start looking at this and go, wait a minute, I'm adding 5 to my variable, so wouldn't it have moved 5 units to the right? And here I'm subtracting 3 units. Wouldn't I move 3 units to the left? But notice the exact opposite is happening. So fx plus 5, I'm also going to get 5 units to the left instead of 5 units to the right. So it seems to be backwards. When I did the vertical stuff, if I added 2, I moved up. If I subtracted 2, I moved down. But here it seems to be the exact opposite. I subtract 3, and I move to the right. I add 5, and I move to the left. What's happening here? Well, we'll come back to this in a second. Let's look at another example. Recall that the vertex form of a quadratic looks like this. Is a times x minus h squared plus k, when the order pair hk is the location of the vertex. Now, let's say that a equals 1, k equals 0, and so all we have is y equals parentheses x minus h squared. So the vertex location in this case, again, if I follow what this says, is going to be the form of h, and the second component k is 0, so it looks like that. So The vertex location is h comma 0. So now I have three graphs in front of me. This blue one, well, not blue one, but the ones that has the vertex at 0, 0. That one is f of x, meaning in its simplest format is x squared. This has to be my basic function. F of x equals x squared is this one right here with the vertex at 0, 0. So what about this function? What is this one? I'm going to call this function g of x. So if I were to write g of x in terms of f of x, and now that I figure out what we have done, it looks like maybe then, it looks like if this graph has shifted 2 units to the right. So in terms of writing this in terms of f of x, since I've shifted 2 units to the right, it looks like I've done that. And if I write it as an equation now, notice my original is x squared. So as an equation, there's my something squared, which is what the original function looks like. When I'm going to drop in, here is x minus 2. What about the other one? Well, the vertex again is 0, 0. And notice how nicely this plays out. There's my original, and looks what I've done. H is now a negative 2. Just like I said it should have. What about this one? Well, again, I'm going to call this h of x, this function. If I forget all about transformations and just write h of x again in terms of f of x. Let me not do that first. Let me just write it in terms of what I said the function was, which is x minus h squared. The h now is a negative 4. So here, pay close attention. I'm about to write it exactly as it's written here. So the way this is written is x minus some value of h. I wrote this wrong over here. The value of the x component is a negative 4. The y is a 0. There is 2, 0. So if I would follow this formula, it says, okay, just put the h vertex here, but make sure you write this. So this has nothing to do with that negative 4. Now I'm going to write in negative 4, and I'm going to square it. When I do that, of course, I can simplify this, subtract an opposite. I can think of this nothing more than adding. And now I have, just like we said would happen if I were to write the following again using function notation, f of x plus 4, it looks like I have shifted from 0, 0, 4 units to the left. So you see this equation, the way it's written will produce the correct shifting. And this is again from the vertex form of a quadratic. So we need to kind of pay close attention to how this is written. This is written so we can read the vertex without having to think about left or right. Whatever the h is for the location of the x part of the vertex, I just write it down, but it has to be written as x minus something, okay? And then I could read it. So if I, for example, have something like this, draw up another one. I'm going to do another quadratic, since we're talking about quadratics. M of x equals x squared. All of a sudden I realize that, okay, this is just that basic function where it used to be the vertex is 0, but the way to think about it is I can think of this adding 7 as subtract a negative 7. So at that point, I realize that I have been shifting 7 units to the left. Okay. Now let's look up the one we just did a minute ago. If I were to write this equation down, what does it look like? Well, here's my original one. F of x equals square root of x. Now let's call this one that's been shifted to the left g of x. So it looks like what I've done is the following. G of x is take the square root of x, but I'm going to do the following. X and then minus, and then I'd write down the position that this one particular point moved to, which is -5. And all of a sudden I have my equation. When I clean it up, it just looks like the square root of x plus 5. Pretty nifty, huh? So it still doesn't explain why this is happening. What's the magic about this minus sign? We'll get that to in a second. There's something visually that you need to see, okay? And this function right here, I call this, I'm running out of cute letters, let's call this n of x. So in this case, if I were to write n of x, I can see that it's the same function, just shifted. There's nothing else going on except shift, right? A rigid movement. So if that's all that's happening, it's a rigid movement. All I need to do is again x minus, there's my minus, and then write down the number that consists of the shift. In this case, I need, because it's rigid, I only need to view one point because this whole thing is rigid, meaning I'm not distorting it in any way. So then I realized that this point used to be 0, 0, has now been moved to 3, 0, but the x component is a 3. Again, notice the x's are sitting here. What's my x component? Well, it's a 3, and there's my equation. So by writing that negative, I could just read the number that's sitting there, and that will tell me which way the shift is going. But it has to be written as the original variable minus what, and now the shift takes place. If it's written this way, again, realize that you can go backwards and write it this way and then read the number. But again, it doesn't quite explain what's going on. Here, I run out of room, so let me go back to the nice graph where I have more room to look at that. So here's an observation. What has happened here? Let me look at this point right here, which is 0, 4. Where did that go? Well, it looks like that point went to this location. Okay. But if you start looking at something at this whole thing, when I move either left or right, you'll notice that the y values are not changing, right? So in the original one, 2 produced a 4. In this transform, now -2 produces the 4. In this other one, it looks like 4 produces the 4. But in each case, the y value of 4 is not changing. It's staying rock solid. So here's a way to sort of think about this. What we're trying to say is this. Let me go back to my original. The original one here is x f of x. And I'm not going to try to fully explain it because you have to kind of wrestle with this idea. So -2 produces 4. 0 produces 0. So in fact, I'm going to just, this is a nice one to kind of put a few more points. 1 squared is 1. 0 squared is 0. -1 squared is 1. And 2 squared is 4. Okay? But as I just pointed out, for a given y value, those are not changing. What's causing changing is the x value. So one way of thinking about this is this. I'm going to choose this h of x. So I'm going to put in 4, 1, 0, 1, 4. And what is it that I'm entering into this h of x function? Well, it looks like h of x, I am changing the equation to this. So now the input looks something like this. Okay. All right. So in other words, my input goes here. And then I add 4. So this is what you're going to wrestle with. Another way of looking at it is that 2 produced 4. Okay. Now -6 produces that 4. Now watch this. If I enter -6 into this, what happens here? Well, -6. So what it's asking is it's -6, right? It's asking for it. So I'm just, it really goes right here. But immediately what's going on? -6 plus 4. Again, you can see that this is the 4. -6 plus 4 is what? -2, and -2 produces 4. So again, you have to sort of think about this for a while, what's happening. I have different ways of thinking about it, but this video started getting too long, and I'm not sure if it would resonate with you. But I like to think of it as a time travel thing, or a thing about speeding things up or slowing things down. So another way of thinking about it is, look, I want to get a 1. 1 used to produce 1. So what do I enter here? So this whole output, this x plus 4 becomes 1. Well, in this case, if I want to produce a 1, what is it that I need to enter? Well, I need to enter a 1 here. Sorry. Put this back in. To get a 1, what is it I need to enter here? A -3. So now -3 plus 4 is 1. 1 gives me the 1 that you see right there. Okay, what do I want now? Now I want the output to be a 0. What do I need to enter here so that I get this input of 0? So if I entered a -4 into this, -4 plus 4 is a 0, and 0 squared is 0. Back again. Again, what is it that I want? A 1. So what is else I can enter here? Well, I can enter again -3. That's a possibility. Can I do anything else? No, I'm sorry, that -3 produces a 1. If I entered a -5, right? I want to produce a -1. -5, enter a -5 into this. -5 plus 4 gives me -1. -1 gives me 1. Okay, so am I hitting, again, you can see the graph right here. Am I hitting that? Okay, let's find out. -6, 4, great. -3, where's -3? Again, I did these out of order so you can see that I'm not trying to josh you. -3, what does that produce? Looks like it produces a 1. So -3, 1. Yep, there it is, -3, 1. What about -4? -4 is here. Yep, that produces a 0. About -5? Well, here's -5. Read across, and it's a 1. So -5 is a 1. And there it is, -5 is a 1. Just one more here. I want to get an output of 4, but before a 2 did it, what can do it now? Well, all right. I'm going to input something. So when I add this, what I get is a +2. So if I entered a -2, add 4, that gives me a +2, and I get that 4. Okay, let's see. -2 is right here. I enter this thing, boom, boom. Yep, there it is, 4. So this is again, you have to wrestle with this, but you can start seeing why this thing is occurring backwards. The horizontal, everything that happens horizontally is always backward. If you think, gosh, it should move to the right, it's really moving to the left. If you think it's moving to the left, it's moving to the right. So everything horizontally is backwards because, again, really the focus is the y's are not changing. What's changing is the x. And because of that, all of a sudden we have to think of it from a very different perspective. Let's, for example, graph the absolute value of x plus 5. So I know the original is going to be, is called the original here, g of x equals the absolute value of x. So the original is right here. 0 equals 0, 1 equals 1, 2 equals 2, -1 equals 1, and -2 equals 2. Again, this is just so we have an idea where the original one is located. So what is this one? Well, it says x plus 5. So again, the way I'm going to write it now is this. And so instead of writing plus, I'm going to write subtract a -5. And now this tells me the positioning. I can, because this is rigid, and this is a fairly, I mean, this is straight lines. All I need to do is move one point, but I'll move the rest of them too. So the original one had 0, 0. The new one will have, again, now that point gets moved over 5 to the left. So notice the y remains 0, but now the new x that will produce that 0 happens at 1, 2, 3, 4, -5. Because this tells me now that I'm going to subtract -5, I can read this as the position. So that point goes right here. And again, I can redo this based on, again, this being rigid. If I move over 1, it should go up 1. If I move over 1 to the left, it should go up 1, right, to recreate the picture. But again, if you're not seeing it, also you can think about, okay, a -1 is 1. So again, a -1 is 1. That's my original one. This new one, again, what is the new one? Let me write this a little differently. The new one is this. So when you think about the new one, it says, okay, what do I need to enter into this? Again, I want input of 1 so that when I go x plus 5, I get a 1 coming out of here. So again, you notice that a -6 added to 1 gives me, -6 added to 5, sorry, gives me a 1. Absolute value 1 is 1. So again, indeed, that point has been shifted 1, 2, 3, 4, 5. And there's my 6 popping out of there. What about this one? Again, this other +1. Again, another thing that will produce a +1 is the -4. So entering a -4 into this, add 5 to it, I get +1, absolute value 1 is 1, and that's exactly what's happened to this point. 1. And it's right sitting right there. Actually, I think I got these two backwards. Yeah, this one would be 1, 2, 3, 4, 5. Yeah, that was that one. This one is the other one. 1, 2, 3, 4, 5. Yeah. All right. So given the function f of x, the function of g of x equals fx minus b, where b is greater than 0. So again, this is a positive number when I write it, is the function of f of x transformed by horizontally shifting b units, in this case, to the right. given the function f of x, the function g of x, which equals f of x plus b, where b is greater than 0, is a function of f of x transformed by, and again, now the way we're going to look at it is this, is going to be b units to the left by horizontally shifting b units to the left. However, it is much easier to think of f split as, and then I can think of it this way. If you see additions, change it to subtraction and the opposite of whatever you were doing, where b again is greater than 0. So the horizontal direction movement matches the value of the number, whatever b happens to be. And of course, if all that fails, just play. Grab any function that you could think of. I'm trying to find a good one here. I'm going to write x. Again, notice here's my original one. Let me turn this one off. If I go x minus 3, then all of a sudden you'll notice that the green line has shifted 3 units to the right. If I come over here and write minus 6, now it shifts 6 units to the left. If I come over here, write 2, it shifts 2 units to the right. Again, I'm keeping an eye on this point. We can see the whole thing shifts, and it's completely parallel, so you realize there's no distortion going on. And you could be here all day, enter -7, and boom, notice now it's moving to 7 units to the right. If I entered -7, now it goes to the left, and so on. So you can play all day here.